We will continue with solving trigonometric equations. In the first part, we started from very simple examples, and our focus in first part was actually how to use correctly a unicircle, and also how to work with domain, or if you like, with range of possible values of solutions. In this part, while still we will keep focusing on applications of unicircle and still working with domain, we will go on, I would say, one level up, actually a bit harder questions. I mean, not harder, but a different concept, better to say. While in first part are questions that you have to understand, that you have to be confident enough for your level, this part may be more related to one level up. I mean, equations of this type definitely you will meet on your final examination here. First example in this part will be to solve equation sine x on 3 equal cosine x on 3 and x taking values from 0 to 2 pi. So we said right at the beginning, when we start discussing trigonometric equations, we said that our target is always to come to the simplest possible form for some trigonometric equation, like sine x equals some number a. In first part, usually we had equations where we had only sine function or cosine or tangent, not mixture of two different ratios or trigonometric functions, if you like. This example is one example that we should learn how to work when we have sine and cosine, or sine and tangent, or cosine and tangent, when we have them at the same equation. So remember, we can solve equations like this, but definitely angles here must be the same. Otherwise, if angles are not the same, that is quite more level above your level that you need, so we won't work with that, but with those when we have mixture of two different ratios, then we have to learn. So our target is again, and the way on which we are thinking is again the same. We are targeting to get this. But how to get from sine x on 3 equal cosine x on 3 to get the same ratio? Well, we have to call two formulas from trigonometry that we already learned. So we have to call those formulas to help us. I wanna remind you. We have sine theta on cosine theta equal tangent theta, and the other one is sine squared theta plus cos squared theta equal 1. So if you remember when I said to come to the simplest possible form, we need to apply algebra and some trigonometric knowledge especially those two formulas, to proceed to come to the simplest form. But again, looking this example, where to go from here? If you're looking like this, maybe you can apply this formula, but not power 2 anyway. Here is just power, linear power. So in that case, will be some square roots here, and the equation will be more complex. However, if we divide this equation by cos x on 3, then what we have? Here we have sine x on 3 on cos x on 3 equal, and here cos x on 3 divided by cos x on 3. Of course, this is tangent. This is tangent, so we can write tangent x on 3 equal, and when you cancel, this is equal 1. So simply by dividing this equation by cosine x on 3, we are changing our equation, and we have one equivalent equation that is the simplest form of trigonometric equation, and now we are simply solving just equation tangent x on 3 equal 1. Of course, we need a unit circle just to see what we are doing. Tangent is here on this line, and equal 1, so this is 1, and that is our angle. So I am saying our possible solutions, because still we can't state those two angles as a solutions, because we have to check what's happening with domain. We have here x smaller or equal to pi, larger or equal 0, but our angle is x on 3, so we have to divide 2 pi by 3, and of course on this side is just 0. So our domain is from 0 to 2 pi on 3, and just to mark it here, 2 pi on 3, so pi on 3 and 2 pi on 3 is angle somewhere here, 2 pi on 3, and basically this is our domain. So we have to pick up all solutions within this domain. This angle here is pi on 4. That is, we can get it from a table of exact values, because we have tangent of some angle equal 1. Then the angle is pi on 4, and there is no other solution, because this solution we can't reach, because our domain is up to 2 pi on 3. So there is only one solution to this equation, and that is angle pi on 4. And we can write x on 3 equal pi on 4, and just to multiply everything by 3, we have x equal 3 pi on 4 will be the only solution to this equation. So as you can see, nothing really much to work, or nothing is that hard to understand. Even example are completely different than examples before. Simply just one idea to get to apply this formula, and you can apply this formula when you divide by cosine to make here tangent on this side, and everything else is something what we already know. Okay, we will have a few more examples of this.